What's up, math scholars? We are doing our last lesson before spring break, so that should put a smile on everyone's face. 7.2. We're basically doing slope-intercept form. Do you remember slope-intercept form? Then you'll be successful today. So who's excited? Our last lesson, yeah! I don't know how many subscribers I have, but if you could go ahead and subscribe, that'd be awesome, and hit like, because I do like getting likes. No dislikes. That's not nice. All right, so can you guys repeat after me? Arithmetic.
Arithmetic.
That's like when you're going to learn some sort of math. So I'm going to learn arithmetic today. Okay. How about arithmetic? That's the type of sequence we'll be studying today. Arithmetic. So an arithmetic sequence, I'll write one down right here, would be if they're adding a constant amount each time. So 2, 4, 6, 8, 10. That would be arithmetic because they're adding a constant amount each time. And you can definitely use slope-intercept form to write out equations of arithmetic sequences. Cool? That's what we're doing today. So even though these words are spelled the same, they're said you say them differently. Okay, so an arithmetic sequence is when you add a constant amount between terms, and that constant amount is called the constant difference. It's D. Do you think that constant difference could be a negative number? Yep. So I'll give you an example of something that would have a negative constant difference. 30, 25, 20, 15. That constant difference would be a negative 5. Okay. So we're going to look at sequences. We're going to say yes or no, whether we think they're arithmetic, and then we're going to identify their first term and their constant difference. So 1, 3, 5, 7, 9, yes or no? Do we think it's arithmetic? Yeah. What's the first term? What's the constant difference? 2. Perfect. Now, I know some of you guys were getting frustrated with that homework where I would like write the equation that would generate this number. Spencer especially, because we would have to assign a 1 to the first term, a 2 to the second term, a 3 to the third term, and then think about how to turn something to another. Well, no guessing today. I actually have a template you can use for these today, so you don't have to guess what the equation is anymore. It'll work for arithmetic sequences only. So this one here, yes or no? Do we think it's arithmetic? Yes, just for fun, can you guys tell me what the constant difference is? And just for fun, can you tell me what the first term is? I call it A1. Good. All right, what about over here in part B? No, they're not adding the same amount between every single term. What about number 1 here? Yes, it is arithmetic. Just for fun, what's the constant difference? Negative 3, and then what's the first term? Good job. No questions on that one? All right, so let me show you that template. It's in the pumpkin square. So this is a template where you can just plop in A1 and you can just plop in D, and voila, you have the formula. Now, if you absolutely want it to be in slope-intercept form, you would want to kind of distribute it and make it look nicer, but you don't have to do that. So I'll pause this and let you write it down. Push the button. All right, we're back, and we're going to try our new template for this equation, this sequence of numbers. So first things first, you do have to establish it is arithmetic before you try to use the template. So is it arithmetic? Yes. Let's identify our 2 key terms. What is term 1, A1? And what is the constant difference, D? So let's just plop everything into our template. I'll go ahead and write the template up. It's AN equals A1 plus N minus 1 times D. So you're going to plop in A1 and D, and you'll pretty much have your equation. So A1 is 4, and then D is 5. Done! Got my equation. Sweet. Isn't that easy? So easy.
That's it?
Yeah. Now, if you look in the back of the book, they might have that answer in slope-intercept form, so I'm going to show you how to convert it. But I'd be fine with you leaving your answer like that, like if this is a quiz, okay? So let me just show you real quick how you would convert to slope-intercept form. You would take this positive 5 and distribute it to the n and to the negative 1. So that would just be a positive 5n and a negative 5. And then you would add up the 4 and the negative 5. So it would be a negative 1. So I would accept the answer in the black or the answer in the pink, either one.
How do you find it?
Good question. Ethan remembered there was one more question happening there. And that question was, how would I find the 15th term? What do you guys think? Plug a 15 in for n, so you can either use the black formula or the pink formula. It's going to give you the same answer. So I'll just use pink. 5 times 15 minus 1. What did it end up being? Yep. All right, so it's the same exact prompt. Find the equation for this sequence of numbers, and then find the 15th term in the sequence. Okay? So first things first, yes or no, is it arithmetic? Yes. What is our first term? Perfect. What is our constant difference? Negative 8. This has got a negative constant difference. So let's plop everything in the template. The first term would be 60. I would have my n minus 1, and then I put in my constant difference. So I'm okay leaving it like that. Questions on that part of it? Now we need to find the 15th term, so we're just going to put a 15 in place of n. And we can use our calculator to help us figure it out. That's a multiply sign right there. So it ends up being 60 plus 14 times negative 8. Do you guys get negative 52? Perfect. So easy peasy, right? All right, we're going to do one where the information given to us is slightly different. So instead of using the template, I believe the easiest way is just to use slope-intercept form equation. So here it is. Let's look at the information provided. They are saying that one term of the arithmetic sequence is a sub 19 is 48. That's a fancy way of saying that the 19th term in the sequence is 48. I'll just use x's and y's. Doesn't matter, a's and n's, x's and y's, doesn't matter. The constant difference is 3. Now, question for you guys. What's the equation for slope-intercept form? Good. I feel like we've used it this week a bit, haven't we? Where would the constant difference come into play as far as slope-intercept form is concerned? It'd be your slope, actually. It'd be your m value. Does that make sense? It's how much it's growing each time. So this 3 would get placed in for m. It would be up to us to solve for b. Anybody have ideas on how to do that? It's Algebra 1. We did it last year or 2 years ago. Not quite yet. We need something in for x and y. We need something in for x and y. Yeah. If you put the 48 in for y, and you put the 19 in for x, you will absolutely have all the information you need to solve for b. This would be all coming back to you. All those Algebra 1 fun memories. So 3 times 19 is 57. And then we'll subtract that 57 over to the left-hand side. Get our b value. So our final answer has that b value in it, has the slope in there. Constant difference is a slope. You can write a note to yourself, my constant difference is my slope. That's like the concept of the day. And then you're on your own to solve for b. Now, just for fun, if I said, let's find like the 30th term, how would you do that? Put a 30 in for x. For x. X is like the whatever number of term that you're on. And if I would graph this, because they do mention graphing, would I connect all my dots with a line, or would they just be dots? They would just be dots. No connecting any of these with sequences. You can't have decimals. Okay. And we're back. So a slightly different problem, but same concept. We're still going to be using slope-intercept form. The information provided is different this time. what they're providing to us this time is 2 terms in our sequence. Term 8 is 21, term 27 is 97, and we pretty much have to pretend we're Algebra 1 scholars right now. So, any ideas? We need the slope and we need the intercept. Which one should we find first? The slope. Definitely the slope. So we actually did the slope formula this year, not too long ago. y2 minus y1, x2 minus x1. So let's do 97 minus 21, 27 minus 8. We did it on the rate of change chapter test, I remember that one. It was a little dreadful. I think people tried typing it all in at one time, so only do little pieces. 97 minus 21 is 76. 27 minus 8 is 19. And now divide the numbers. If you absolutely want to do it all at one time, you would need a set of parentheses around the top and the bottom. There is your constant difference, your slope. 4. So at this point, I definitely need more workspace because I still have to find my y-intercept. So I'm going to go ahead and put my 4 in for m. Who has an idea of how we can solve for b? Plug in what numbers? Pick your favorite coordinate. Doesn't matter what coordinate. I'm going to pick this as my favorite coordinate because they're both positive numbers and they're both relatively small. You'll put the 21 in for y, you'll put the 8 in for x, and you'll solve it for b. So 4 times 8 is 32, and I'll subtract that 32 over, and I'll be done because I'll have my intercept, a negative 11. So our final answer is got the 4 in for slope and the negative 11 in for intercept. And you can use that to generate any other term that you would want. Questions? I'll pause it and let you write it down. Alright, I do want you to try this one all by yourself, so I'm going to pause the video and you can pause the video and try it. This is not your graduation problem, because we're not quite done with the lesson yet, but I still think you need to practice this by yourself, okay? All right, how's it going? You find your slope first. How many people got their slope to be 5? Good. You pick your favorite xy value. It doesn't matter. If you had used the 16 and 71, same answer. You would get the same answer. The intercept ended up being negative 9. Who got it? Now, if this is bothering you, because they're always saying find the nth term and stuff, and you're like, I have x's and y's, no problem. You could rename this a subscript n equals 5n minus 9. It's still the same exact formula. It still generate the same exact numbers, but you might look a little bit more like a true mathematician if you've got your an's and your n's. Okay. Sound good? Thumbs up? All right, we have one last concept to cover, and we'll be done. So this is another shortcut to add to our shortcut board. Our shortcut is located right here. It's a shortcut that you can use if you have a really big arithmetic series that has a formula that is in slope-intercept form. So you write down the shortcut. I'll give you an example of when I could use this. Alright, so I just wrote an example down of where we could use this. It's a rather big series. There's 20 terms. I personally wouldn't want to make a chart with 20 numbers. Brittany? The little formula thing? Yeah. Okay, so I have this series. It's 20 terms. I probably would not want to make a chart with 20 numbers in it. The equation itself is in slope-intercept form. If that means it's arithmetic. So if you're in slope-intercept form and you are arithmetic, you can use this as your shortcut. So let me explain what everything means. The overall sum would be n. Now n is how many numbers are in the series. So that'd be a 20. Parentheses. A1, that's a fancy way of saying the first term. Just put a 1 in for n to find your first term. What would that be? 8, good. Plus a sub n, that's the last term in the series. You'll put a 20 in for n to get the last term in the series. 103 over 2. So what this kind of does is it finds the midpoint of the series. It's got the first term and the last term. It's divided by 2. It finds the midpoint of the series. And it multiplies by 20. So what's 8 plus 103 over 2? 55.5. And then you'll just multiply that by 20, and you'll have it. The sum is 1110. Isn't that cool? So that shortcut will work if the equation is slope-intercept form. Yeah? The 8 is the first term. So you basically put a 1 in for n to get the first term. You put a 20 in for n to get the last term. Any other questions? All right, I'm going to put the slide up with the homework on it so people watching the video can see. I would suggest taking a picture of it. It looks longer than it actually is, just the way I have it written out. But you'll be fine. This is your last homework before spring break, so that should put a smile on your face. And thanks for watching the video, everybody at home. Have a happy day.